So hey everyone, thanks for coming. So I'll be talking about TypeScript, especially how you can make your code safer when you're dealing with like external data. So what's the problem here? Let's say you have a beautiful code base, everything is completely type safe, like no problems. Well, actually, you can still get some really weird type bugs. So, for example, say you have your backend, which is, for example, like a Django app, and a front end in TypeScript. In your backend, you have this object which has an X and Y, and when you send it to the front end, you forget to send the Y. But then in your front end, you're expecting something with an X and a Y. So usually what you do when you get external data is you kind of convert it into the type you expect, either implicitly or with like the kind of as type version. And this doesn't actually check what you're receiving. So here nothing happens at this stage. But then later on, when you go to use that object, if you try to use Y, you get undefined, even though you're not supposed to do that. So, okay, let's take kind of a step back. Also, please interrupt me if you have any questions at any point, or if you have, anything to say. But yeah, let's take a step back and like kind of think about what type languages are, like the point. What's the point of a type system? So the main one is we wanted to prevent bugs, right? So the way we do that is we want to turn as many runtime errors as we can into compile time errors, so that if you try to compile your code, if you have an error, it'll get caught at that point. Your CI will like reject your code. You won't be able to push any bugs to production. You still need some runtime errors, but they should be for stuff like the network failed or like your hard drive is on fire, or but not for like you forgot a semicolon at line 21. So yeah, there are kind of two main properties of type systems. They sound complicated, but I promise it's really simple. So they're called soundness and completeness. And soundness is just saying, if your type checker accepts your program, then your program doesn't have any bugs. That's kind of, well, bugs as far as your type checker is concerned. So for example, in this example, in the example I just showed, this is not sound because your type checker said that something had a type when it doesn't actually have that type. And incompleteness is kind of going in the other direction. If your program doesn't have any runtime errors, then it should be accepted by your type checker. And usually that's not quite the case. It's difficult to have both at the same time for like interesting languages. I don't know. Yeah, the reasons are kind of more theoretical and not really in the scope of the talk. The idea is like if you're lacking in completeness, then usually that means you need to kind of rewrite your program to satisfy your type checker. And if that's not possible, then maybe you're doing something too advanced and you need like a better type system. So yeah, as I kind of mentioned, TypeScript is different because it's kind of JavaScript in disguise, right? So any JavaScript program is a valid TypeScript program, so you don't really get any soundness because of that. So in particular, it's really easy to just tell the type checker to just ignore bugs, or with the any type or the as keyword, you're doing like really unsafe stuff, and it just lets you do that. It's really happy for you to do that. Okay. Oh yeah, so as like a purist, I would say it's not really a type system, but more like a static like bug or like linter than an actual type system, because soundness is really important when you design a type system, in my opinion. Yeah. So I just mentioned any, and there's also this thing called unknown, and it's important to kind of understand what these two types, like what they really mean and what the intention is behind them. So yeah, some functions, for example, JSON.parse, when you take in like an arbitrary string and it returns you a parsed object, this returns any, and any as a type means, okay, trust me, this has every single type you can possibly think of, just don't bother checking it. And yeah, obviously that's not a very useful like assertion to make. And then unknown is kind of opposite of that. So when you get unknown, you're saying, I have no idea what this is, and I need to be really careful. If I want to use any property on that, I need to check that it exists, things like that. So yeah, basically an unknown object, you can't really do anything with it, and any object you can do everything with it. So the question is, how do we handle unknown? Because usually, well, if you're doing things right, and whenever you have stuff coming in from the outside world, it's unknown to you. You don't really know what it is. So you need to find a way to convert it into your like model of the world, which is your type system. So you've probably done something like using the as keyword. So what this really does is just tell the compiler, look, I know something you don't. This x, which you think is unknown, I know it's a t. Just trust me. And so the compiler just goes, okay, fine, and it doesn't do anything. So if you look at like kind of the output JavaScript, this as just disappears and nothing happens. So if you're wrong and x isn't actually a t, then you will get maybe an error somewhere else. So in the example I gave at the beginning, because the property didn't exist, you get undefined down the road. But to pick something a bit more subtle, if you're expecting a number and get a string instead, and then you try to add that number to something else, then you start getting like a different string. It doesn't fail. It might like lead to corrupted data somewhere in a really weird place. So yeah, it can be a bit dangerous. So yeah, this is basically the same as when you have something that's any and just converting it into a type. It doesn't check anything. So how do we fix that? So the first idea is to think, okay, we want something that's exactly like as, but which actually does checks. So it would be a function that looks kind of like this. So it takes unknown, returns a t, and it does some checks inside. Yeah, and the idea is to fail at that particular point if your assumption is wrong, in order to prevent like further damage. And the problem is you can't do that. Yeah. So if you try to implement this within Typescript, you will run into some, well, yeah, you're not going to be able to do much because if you get a type parameter, you can't do a computation based on that type parameter. So you can't say if this type parameter has a property and that property has type string or whatever. You can't do that. So if we wanted that function, it would have to be implemented by Typescript as like the language feature, which is not going to happen, I think. So what can we do? Well, we can implement it for any type you want. So because the problem is only doing it generically. So for example, here you can check that something that's unknown is actually a string. So you just look at the type of x. If it's string, then at this point you know that x is a string, so you just return it, and the compiler is happy. And otherwise, you throw an error. So yeah, this works as a proof of concept, but it's not really scalable because if you have every time you have a type, every time you want to convert into a type, you need to write a function specifically for that type. And types can be very complex with lots of like nested structure, very like, for example, if you have this or that, you would have to branch out. Basically, it gets unmaintainable. And whenever your types change, you need to update that function manually, which is really not ideal. And that last point, not as much of a concern maybe, but it adds even more work, like computational work at runtime, because you're doing extra checks that wouldn't otherwise be there. And overall, you can't completely avoid this because you're essentially taking arbitrary data into your program. You want to do some validation at some point. But because when you're running TypeScript or JavaScript, it doesn't have any concept of types. It doesn't really care about them. It will do some kind of check every time. For example, if you want to access a property on an object, every time you do that, JavaScript will look into the object, see, okay, does that property exist? Yes, no. And then, for example, if you want to call a function, it will look into the object, does that exist? Yes, no. So you're doing a lot of extra work that might not be necessary. But yeah, so for example, to compare with this with Java, in Java, once you know that something has a type, you're not going to, it knows which properties exist on that object. It's not going to check the type of the object every single time because it has like stronger guarantees. So I've listed a lot of problems, and I think it's time for some solutions. So one thing we can use is called JSON schema. So basically, a JSON schema is just a JSON object which defines your valid data structure. And it's nice because it's independent of language and framework, so you can use it with your like Python backend, your Typescript frontend, or anything you want, any combination. And it's, for example, used in OpenAPI specification, which is like a way to make sure that your different like services, your front-end, back-end, are in agreement as to what your types are and like how they communicate together. So here's an example of a very simple schema. I've written it inside a TypeScript file because it's going to be needed for the next step. But so basically, this is defining a person object which has just like a name property as a string. So the first line, we're saying that a person is an object, and this object has some properties, and it has a property called name, and name has the type string. And it's also saying that the name property is required, so if you don't have it, it's an error. And it's also saying that there are no additional properties, so if you have anything else, it's also an error. And now I'm going to use two libraries. So the first is called AJV, and it's a library that allows you to do validation of like values against schemas. So it will tell you whether a value conforms to a schema. And also this really cool library called JSON schema to TS, which is something that automatically converts your schema into a TypeScript type. And it does this without like any kind of it doesn't generate more TypeScript files. It just you see this like from schema type. You give it the type of your schema, and it automatically infers the actual like type of the data. So really cool. I have no idea how it works. There's like some TypeScript magic in there. But the nice thing about it is you don't have to write your person type as like a JSON schema and also a TypeScript type. You can just do once, which reduces like the risk of errors and also tedious work. And now the last little bit is we take the schema and we compile it into this like a validate person function. So this just creates a function which tells you is this a valid person or not. And now we can finally do some actual like runtime validation. So this is just like a very basic Next.js app, or like a fragment of it. So just fetching an API, calling an API, getting a response, a JSON response. And then, so as you can see at this point, person is like any, really should be unknown, but any is what we get due to the type definitions of JSON. And now we test if it's a valid person. And then inside that block, person now has a type person. And you also know that it's been validated. So we can then do whatever we want with the person. And otherwise, we can give some kind of error. And I'm just going to do quick. So this is how it looks like when everything is working correctly. So it just prints the name. Now let's see what happens if my API is in French for some reason. So it returns doesn't return name, it returns name. So we reload, and we get invalid person. Nice. Okay. We can also test if we give it some kind of number, and it's also invalid. And the interesting thing is, if you compare it with like not having, so let's say we have a wrong API and we don't have any validation. Then here we just get undefined at this point, which we weren't expecting due to like our type definitions. Yeah. Oh yeah. And the final little bit, which is quite cool, is yeah. So if you have an error, it gives you like a very detailed error message, or like error. It gives you a list of all the errors during the validation. And we did a very detailed message. For example, here, the problem is that the name property was missing. Or for example, if we give it number, it will say that the name property has the wrong type. So yeah, pretty cool. So to kind of summarize, we've seen that we can do runtime validation with minimal boilerplate, without duplicating our types, and without like creating really difficult to maintain functions. Obviously, it's not perfect. For example, I don't know if you noticed that the error handling is a bit weird. So in order to get the errors, you have to look inside the function. Yeah, the errors are still kind of in the function for some reason, so you have to look at, you get kind of the errors from the last time you called the functions, which is quite confusing. The other problem is that the schemas have to be inside your TypeScript files, and the reason for that is that you need them to be kind of this like as const. So as const does what this does is it tells you that this key tells you that the type of this property is like exactly object, not just a string, because otherwise TypeScript kind of generalizes from what you get. So if I remove this, then this is like type string, string array, boolean, which is not enough information for the like typing for this of the schema. So we need this here. And because we need this here, we can't have this in a JSON file somewhere. So it's more difficult to share this definition between, say, your front end and back end if you have like a non-TypeScript back end. And yeah, there's still like a bit of a trade-off between the safety of your code and the complexity. Like we had to install 2 completely new libraries. We had to write like JSON schemas instead of types, which we are familiar with, and we're just like adding more work at runtime. So it would be nice if this wasn't the case. Like the safe way should be the easy way, but yeah, that's what we have in TypeScript. Yeah, I'd recommend kind of. So this is really cool, but I'd recommend still like taking a step back and thinking, okay, do I really need this? For example, if you have like already shared type definition between your front end and back end, then it might not be necessary. But for example, if you have like a risky endpoint, like a third-party endpoint, or like some API you don't really trust, then this would be useful to catch bugs. And yeah, I think these are the 2 references of libraries I talked about, and that's pretty much it. So yeah, do you have any questions?
Did you build the error handling yourself, or it comes up with a problem?
No, it's from the library.
Can you add like logging into it?
I'm sorry. Yes. Yeah, so I literally just like console log the errors from the validation function.
Just a small bit of trivia. Do you know who made JSON schema GTS?
I don't know.
I'm asking that because he works in Tour de France.
Oh, okay. So I thought it was related because I saw it being used in in the Swan project.
Yeah. It's actually become quite famous now, and it's got 2.5 million weekly downloads. I just checked.
Yeah. It's a really cool, really impressive.
I tried looking into it. It's actually very complicated. I can't understand it.
Quite a big package as well, and it's got about 1 megabyte. So installing it, maybe with caution.
I guess it shouldn't impact your your runtime code because it's only a type definition, so it will be stripped out of your JS, but it will make your compilation times. So probably.
Would you add as a type dependency?
Um,
Can you hear me?
oh yes, sorry.
Have you looked at some alternatives like Zod or Yop? You know, they do similar things, or are they less advanced, more advanced?
I've used Yup for form validation before. I guess the problem with Yup to me is you have to build your validation as a completely different thing on top of your types. For this, I wanted to make sure that we didn't duplicate kind of the type definition with a different I guess validation layer, if that makes sense.
Yeah. I think Zod might do that, but I'm not 100% sure.
I haven't looked into all that. Look, thanks.
Yeah, Zod is becoming quite mainstream sort of static type checker for schemas with especially JSON objects. So that one's also another example, probably. But please support the Theodo project.
Have you used it on any project?
No, not yet. Although I'm going to try it maybe one of those. If Chloe doesn't get me. Okay, I can answer your last question.
Oh, did you add into type dependencies?
Oh, I did not. Probably try.
Yeah, it'd save you some size.
Anything else?
Thank you.
Cool. Thanks.